Hello, human geometry. Welcome to Properties of Parallel Lines. Our lesson today involves proving theorems about parallel lines and using properties of parallel lines to find angle measures. We'll be pulling this out of our textbook, section 3.2, and looking at some of the things that happen when lines are parallel. We're going to go heavily into what we did yesterday, okay? So this draws on that very much. And in order to set us up, I'm going to go with a couple of slides that were on the video from yesterday, just as a review. First of all, we got to understand the nomenclature and what we're talking about here. So again, reviewing this from yesterday's video, the yellow areas are what we call exterior because they're outside of lines L and M. Remember, T is called a transversal. It's a line that crosses two other lines. And then the red area is called the interior between L and M. And that made it so that certain relationships are going to be defined. Okay? So interior angles 3 and 5, along with angles 4 and 6, are called same-side interior angles. So there are two pair of same-side interior angles in this picture. Two pair of alternate interior angles, those being 3 and 6 and 4 and 5, opposite sides of the transversal, interior between L and M. Corresponding angles lie on the same side of the transversal and in corresponding spots on their respective crosses. Okay, so 1 and 5, 3 and 7, 2 and 6, 4 and 8 are called corresponding angles. And then finally, alternate exterior angles. Exterior angles outside of L and M, opposite sides of the transversal. 1 and 8, 2 and 7. So there's our review from yesterday's package. If you need to go over that again, you should replay these few slides. Now, I know what you're saying. You're saying, Mr. Minardi, you left off one of my favorite videos, or favorite slides from yesterday, and it was this one. Certain important characteristics crop up. And you're saying, remember when you said this? Well, Mr. M, what are those important characteristics? Here we go. What happens to these angles in our figure if lines L and M are parallel? And I want you to notice this, these little marks right here, little triangle marks. Okay, those are going to be used on our diagrams to indicate when lines are parallel, okay? Now, if L and M are parallel, we have certain relationships that are going to crop up here between those four different types of angles, four different angle pairs and sets of pairs, all right, that will only be true if L and M are parallel. So let's start with a postulate, okay? Now, if L and M are parallel, this is going to be a postulate, which means it's an accepted statement of fact, okay? Same side interior angles, like 3 and 5 and 4 and 6. They have to be supplementary. In other words, angle 3 plus angle 5 adds up to 180 degrees. Angle 4 plus 6 also have to add up to 180. So this pair of alternate interior angles, same side interior angles add up to 180, and so does this pair here. Good enough? All right, so let's look at what that means. Okay, using that postulate, let's just make an assumption that angle 3 equals 70, and I just kind of picked that at random. But if 3 equals 70, well, then look what we know. Because 1 and 3 form a linear pair along line T, well, they have to add up to 180. Therefore, if 3 is 70, 1 must be 110. Likewise, angles 3 and 4 also form a linear pair on line L, right? Therefore, if 3 is 70, 4 must be 110. All right, now, by our postulate that we just talked about, 3 and 5 are same side interior angles. Therefore, they must add up to 180, and angle 5 has to be 110. Finally, because 5 and 8 are vertical angles, 8 must be congruent to 5, must also be 110. So if angle 3 is 70, 1, 4, 5, and 8 are all 110 degrees. Carrying on with the same argument, if 3 is 70, well, angle 2 must be congruent because 2 and 3 are vertical angles. All right? Now, look at this one. If 4 is 110, as we proved on the last slide, right there, 4 and 6 are same side interior angles. So since 4 is 110 and they have to add up to 180, 6 must be 70 degrees. And if 6 is 70 degrees, its vertical angle 7, angle 7, must also be 70 degrees. So what we have here is one angle, angle 3, if it's 70 degrees, well 2, 6, and 7 must also be 70 degrees. 1, 4, 5, and 8 must all be 110. Now if 3 is not 70, the same relationship is going to hold no matter what the angle measures are. If L is parallel to M, and this is critically important, if L is parallel to M, then all 4 of those red angles have to be congruent. And all 4 of those yellow angles also have to be congruent. Not only that, any one of the red colored angles and any one of the yellow colored angles have to add up to 180. So if you need to digest that, pause the video. But all of the red angles are congruent. All of the yellow are congruent. And any one out of the red plus any one out of the yellow have to add up to 180 if lines L and line M are parallel. Okay. So this leads us to some new theorems that we can add to the original postulate. So here's our postulate, same side interior angles have to add up to 180. But because of those relationships, we now know alternate interior angles have to be congruent. 4 and 5 are alternate interior angles. They are congruent. 3 and 6 are also alternate interior angles. They must be congruent. So there's our first theorem. Next, alternate exterior angles have to be congruent. 1 and 8 and 2 and 7 each form a pair of congruent alternate exterior angles. And finally, corresponding angles, as we illustrated before, have to be congruent. 1 and 5, 3 and 7, 2 and 6, and 4 and 8. If they're in the same position on the cross, they must be congruent. Okay. Now, this is the kind of problem that we're going to face here. Okay? Given that line A and line B are parallel, as are C and D, and again, I want you to notice the nomenclature here. One little triangle tells us these two lines are parallel, while the two little marks here tell us that these two lines are parallel. A and B are parallel, as are C and D. Now, how do we go about evaluating the measurements of 1, 2, 3, and 4? Now, the tricky part is you're going to have to be able to picture different parts of a diagram and ignore the information that you don't need for each of these particular parts. Okay? Here's the example. As much as I'd like to do angle 1 first, I've got nothing in our repertoire. None of those 4, the postulate and the 3 theorems, tell me about the relationship between these two angles. So I'm going to have to start somewhere else. Here's my proposal. Okay? Let's do angle 2 first. And in order to figure out what angle 2 measures, we're going to need to ignore the whole left-hand side of the picture. So to do it, here's what we got. I am going to pull a little computer magic here and wipe out the left-hand side of the picture so that I can evaluate what happens using just lines C and D being parallel cut by transversal B. Now I see 2 and 115 are alternate interior angles. And if that's the case, they must be congruent. So measure of angle 2 has to be 115 degrees by the alternate interior angle theorem. Good enough? So we got 102 labeled, or angle 2 labeled. Next, now I'm going to look at angles 3 and 4, okay? And to do that, I am going to want to ignore the entire upper part of the picture. So once again, let me wipe that out for us. And we will ignore the upper part of the picture and look only at lines A and B cut by transversal D. All right. So now with this configuration, I see 115 and 4 are same side interior, same side of the transversal, inside the two parallel lines. Therefore, angle 4 is going to have to add up with 115 to make 180, and that means angle 4 must be 65. Now, I also noticed in this drawing that the 115 angle and angle 3 are corresponding. They're both on the top left of their crosses. Therefore, angle 3 must also be 115, which of course makes sense because 3 and 4, as you notice, are a linear pair and have to add up to 180. So, angle 3 must equal 115 because of corresponding angles. Angle 4 must be 65 because it's a same side interior angle. Now we can go ahead and look at angle 1. And here we go. I see angles 1 and 3 are corresponding, top left. Therefore, the measure of angle 1 must be 115 degrees by the corresponding angle theorem, noting that it's corresponding to angle 3, not to the 115 degree angle. Okay, so you're going to want to get in the habit of being able to ignore certain parts of the picture and just pick out the information you need. To illustrate that, I've got a couple problems here that I want you to look at. Pause if you want to work on them on your own, and then I will reveal the answers here shortly. So for the first problem, find y. And second problem, you got x's and y's to solve for. Which of the postulates and theorems are you going to need to use? And how will you go about analyzing what you need to find out? Answer coming now. For this problem, I see that y and 40 together form a corresponding angle with the 105. They're both on the bottom right of the cross that's formed by this set of parallel lines and this transversal. So the bottom right, both bottom rights must be corresponding, but that 105 is not equal to y, it's equal to y plus 40. The two angles together add up to 105. So y plus 40 equals 105. Y then has to be 65 by subtracting 40 on both sides. Second answer, I'm looking at these combinations and noticing that on the left-hand side, I have a parallel line. Let me make them green. Or a pair of parallel lines. Oh, great green. Pair of parallel lines here and here, cut by this transversal here. And that configuration looks like what we call same side interior angles. Therefore, 2x and x plus 12 have to add together to make 180. Solve our algebra, we find out x has to be 64. We're going to do the same thing now with the right-hand side. Only this time, we picture these two parallel lines cut by this transversal, and also same side interior angles, which means 3y and the y plus 20 have to add up to 180. And our algebra solves this now for y equals 40. Okay? Finally, an example of a proof that will use this theorem. Pause if you wish to work on it on your own. But given that A is parallel to B, 1 is congruent to 4, can you prove that angle 2 is congruent to 3? Think about it for a moment. Answer will be revealed shortly. Pause if you want. And here it comes. Follow the proof. Start with our given. A is parallel to B. Look at our same side interior angles, which tells us 1 and 2 add up to 180. 3 and 4 add up to 180. Our second given says 1 is congruent to 4, which means that I can do a substitution and pull out, what did I do? I pulled out the 4 here and replaced it with the 1. Okay? And in that case, I look at these two lines here and here, which tells me that 2 and 3 both add up with angle 1 to make 180. By the congruent supplements theorem, that means 2 and 3 must be equal. Therefore, 2 and 3 must be congruent by the definition of congruent angles. All right, so get to know these, all right? They will be critically important. You're going to use them over and over again, both in problems and in proofs. Know them and love them. They are your friends. I will see you guys tomorrow.